So I have not been regular lately regarding the recursive function. But few days back I was just looking at this cutting rope problem. So I built a simple solution for that. I actually found it in in a book. So it is not. Maybe it is also on Leet code. I think it should be because it's a good question. But let's just look at the problem. So what we actually want to do is we are going to get two inputs. One is n, which will be the length of rope, and abc. ABC will basically be the options that will allow us. ABC will be basically the options of length in which we can cut the rope. So like this is like in this example we have the total length of the rope is 5 and we have to divide it either in the length of 2, 3 or 4. These are our options. So what we need to return is we need to return maximum number of pieces that this rope can be cut into. So for example we have 2, 3, 4 as the option, and 5 is the total length, so we can basically cut it into 2 and 3, which equals to the length of the rope, so in two pieces. And when we cut the rope, we basically need to understand that we have to cut the rope completely. So you might argue that we can cut with 2 into 3 pieces, like 2 to 1, but we do not have 1 as the option. So we are not allowed to cut it into the length of 1. Okay, so how we approach to this? So this is a recursive solution. Basically what we are doing is we are taking k is equals to 0 in our rope cut functions. K is basically the number of cuts that we are going to make, and we are basically calling this function recursively three times. First we do n minus a, that is the length 1. Then we do n minus b, that is the length 2. And then we do n minus c, that is the length 3. We call on all these functions, and based on that we have these base cases. Like, so when n equals to 0, we return k. We basically do nothing. If n is less than 0, that means the solution that we are trying is not actually a solution, and this is not a in uh, feasible length that we should use. So we return -1. And if none of these two cases are true, it means that the rope is still not completely, uh, we have not reached the length of the rope. So in that case we basically do k plus plus, because we have successfully cut rope into at least one piece. This basically is just a successful cut. Now let's say when we call this for 5 minus 2, it goes 3 here, and ABC remaining the same, and k becomes 1. Okay, now when it goes inside this for the second time, it will go for n minus 2, that is 3 minus 2. Then it will go for 3 minus 3 and 3 minus 4. So 3 minus 4, this will return -1, so this will end here. This will return 0, so this should be the ideal solution, and it will return k is equals to 2. And this will return this will be 1, so it will lead to k plus plus, k will be 2, and then when it runs again we will get negative values, and for that it will return -1. So just to demonstrate that, let's just console.log x comma y comma z. So we run the function. So what we get here is -1 -1 -1. So first it goes for n minus 2. So when we call n minus 2, it goes to 3, then it will call recursively all these three. And basically, as we know, n minus 2 is not the ideal case, so it will return minus 1 minus 1. And then there will be a case where it will return 2, like n minus 2, and then when it reaches n minus 3, it will return that. So basically we will get two negatives, and uh, at the end we receive 2 2 minus 1. 2 basically we receive from this one, from this one we receive 2, and from this one we receive minus 1. And this should basically be negative 1 in the end. And when we do a maths.max from that, like when we do math.max for this, this is minus 1, from here it is 2, from here it is 2, from here it is minus 1, and from here it is 2. So the final answer is 2. That's all. I do think that we can make this solution a bit better, but we will do that again when we face this in the Leet code. So this was just a, I just thought it's a good problem to bring it on, so I just addressed it. Thanks for watching, and I will bring the Leet code video soon.